In Java's Graphics 2D system, there is a fundamental class named Shape. You can extend the Shape class to create classes of your own that define geometric shapes. We'll be doing that in some upcoming lessons, but right now I want to show you some fundamental operations with shape objects. One of the predefined shape objects is named Arc2D. Like the other shape objects, it requires a Graphics 2D object to be displayed. Also, like the other 2D objects, this one has both a double and float version, and there is a different constructor for each one. Both versions work exactly the same, it's just that one uses float data and the other uses double data. Now, for the examples that I'm going to show you, I use the double type because it's easier, it's the default. And whenever you declare a constant value with a decimal point, it defaults to being a double, and it's easy to put a small d at the end of the number and turn it into a double. Now, this program displays 3 horizontal rows of objects. This call to set arc specifies the dimensions and locations of the first one in the first row. The upper left-hand corner of this one is positioned with the x equal to 10 and y equal to 30. Its height and width are both set to 100. The portion of the circle that this is going to cover is defined in degrees. Now, the only reason I can figure that they use degrees instead of radians is to be inconsistent with the other stuff that we looked at earlier. Anyway, this one starts at 0 degrees, which is straight to the right, and rotates 45 degrees from there. Because the rotation value is positive, the actual rotation is in the counterclockwise direction. If you remember the Cartesian coordinates from algebra, well, here they are again. This last argument specifies the way the figure will be completed. This one is going to be pie-shaped. That is, a line from each end of the arc will be drawn to the center of the circle, making the shape like a slice of pie. The draw method of the Graphics 2D object is used to draw the outline of any shape object, and the arc is a shape object. This arc is also considered to run from 0 to 45 degrees, but it is defined as having a chord for completion. That means the figure is completed by drawing a straight line between the two ends of the arc. The third arc is built the same way, but the figure is not closed at all. The ends of the arc are simply left open. The second row also has a pie, a chord, and an open arc. But these are all beginning at 0 degrees and drawn around the arc in a clockwise direction for 135 degrees. This last row looks about the same, but all 3 of these start at 45 degrees and go around 270 degrees from there. Here's what the thing looks like. The x and y position of each one specifies the location of the arc as being the upper left-hand corner of the shape as if it were being drawn as a full circle. Now, as you can see, all of these in the left column are the pie shapes. That is, they are all closed with lines coming from the ends of the arc to the center of the circle. The second ones in this second column are closed with a chord, a straight line drawn from one end of the arc to the other. And these are just left open, no closure. Now, these are all displayed by using the draw method of the Graphics 2D object. Here is the output of a program that is written exactly the same way, except the calls to draw are all replaced with calls to fill. The fill method of the Graphics 2D object will fill any shape object with the current color. Notice the column on the right. To be able to fill a figure, it couldn't just be left open, so the default is it used the chord method to close the object for the purposes of deciding what to fill. Now, there's more than one way to scale an arc shape. You can use a transform, or you can just set the size of the shape. This row of arc shapes is scaled using an affine transform. The first one is left at its original size. The other three have calls to the scale method of the affine transform to change their size. These arcs are scaled by using the set frame method of the arc object. The set frame method specifies a box in which the arc is to fit. You do that by specifying the position and the height and width of the frame that's to hold the shape. In the second row, the transform is only used to position the arcs. The set frame method is used to shape and size them. And here's what it looks like. As you can see, the top row and the bottom row are identical. The only difference between the two methods of scaling is the way the lines are drawn. But there are some other things that you can do with the lines too, and we'll be looking at that in an upcoming lesson.